Hello and welcome back. This is the start of a major new subject in the language called structs. Structs are a user-defined data type in C. So up until now we've been using the primitive data types that are defined as part of the language, the ints and floats and doubles. And now we're going to learn a way of making our own data types, a user-defined data type, and in this segment it will be short and just show you how to do it, and then in the subsequent segments we will exercise it more and put it into practice. So this one will be short, and I'm expecting you to have to come back and watch this one again. That's kind of how major new subjects work in all areas. So let's have a look now at user-defined types, or structs, in C. Okay, let's start off by motivating the need to have such a thing as a struct in the C language. Suppose we're going to write a program where we want to represent a date, and we could declare three int variables: a day, a month, and a year. So three variables are one thing, and if we want to pass this one thing into a function, we would wind up passing three parameters: the day, the month, and the year. So what we need to be able to do is to associate these three things as component parts of one thing. So a day, month, and a year is a date. That's one thing. So we're going to put them together using a syntax in the language that would allow us to create a new data type that is composed of a day, a month, and a year. So I talk about this fairly often, that this is the foundation of object-oriented programming. We're going to put things together making one thing, and I don't want to call it an object because that word is reserved for discussions of object-oriented programming, but we are going to associate component parts into one other thing. Well, creating structs in the C language, there are different approaches to it, and I want to keep them separate by calling them a name. So we're going to have approach 1, 2, and 3. So here's approach 1. The keyword is struct, and then we use braces to encapsulate the three component parts of this data type. So our new data type consists of a day, a month, and a year, and this is the definition of the data type itself. So struct, and then the open brace and the close brace. This is the data type, and in this one it's the data type followed by the name of a variable. So the variable is my birthday, and the data type is all of this, the keyword struct from here to here. Same as if we said int I, this would be the int, and this would be the I. Okay, this is not a very useful way of using structs because you can't reuse it. We can make one variable of that new data type, but then this data type that we created, doesn't have a name. It's not stored anywhere to be reused. So this approach 1 is the simplest possible one, where you create something that you don't need anymore, and it's not really useful, but it's the first way that we look at it. So here's approach 2. It starts to be more useful. We have the keyword struct, and then we have a name for our data type. So the name of the data type in this example, this is approach 2. The name of the data type is struct date. If we want to declare variables of our new data type, we say struct date, and then we can say birthday, anniversary, New Year's Day, and each of these is a variable of that data type. So struct date, and there's a month, a day, and a year. So what does it mean that this variable birthday has data type struct date? It means, here's a picture of it over here. this thing that we've created called birthday has three parts to it: a month, a day, and a year. So now we're going to introduce the dot operator that allows us to have access to the component parts of that thing. I'm trying not to say that object. So the dot operator I'd like you to read as apostrophe S, or ownership. So we would say birthday's month gets 11, and birthday's day gets 16, birthday's year gets 1980. So what is the data type of birthday's year? It's an int. And the data type of birthday's day is an int, and so on. The data type of birthday is a struct date. So by declaring one thing, we have actually declared three ints because of the definition of that new data type. Here's approach 3, and this one is the most useful and the one that we will be using most often in the subsequent video segments. So we're going to use the keyword typedef, and we're going to define a new data type. So typedef struct month, day, and year is the data type, and then date in all caps is going to be the name of our new data type. So a couple of things happened here. Remember, in approach 1 we had struct and then the month, day, and year. That was the data type. So now we're kind of using approach 1, and we're using a typedef with it. So typedef means I want to give a name to whatever is following. Typedef this data type to be the name date. Now when we want to declare variables of this new data type, we can just use the name of the data type. My convention is to use all caps when you have something typedefed. I hope you'll follow that convention. If you're using a book that doesn't follow that convention, or you're finding other conventions, then that's up to you. But in my segments, video segments here, we will use all caps as something that was typedefed. So date birthday is a declaration. We've declared birthday to be one of these things. And we have the same result as we had in the last approach. We have birthday's month is an int, birthday's day is an int, and so on. Now, of course, when you're designing your structs, you can use any other data types in here depending on what your struct requires. It doesn't have to all be ints. Anything can go in your struct. So let's start looking at how we might use these user-defined types or structs, and here's the declaration that I had in the previous slide. We have a new struct typedef to be the name date in all caps. We can use that new data type the same way we used any of the primitive data types. So here's the definition of a function that takes a struct as its parameter, and when we call that method, what will we pass to it? Well, we'll pass a date, all caps. So birthday is one of those things, and we can pass that to the function. And here's the function definition. The data type of the parameter is the data type that we just defined above, and that means that we're passing in by value this guy here, birthday, is getting passed by value into that function. And inside that function we can use the component parts of the thing that was passed in. So myDate.day is an int, and myDate.month is an int, and so on. And this is an interesting one. I'm not sure we've used this before. %02i. The 0 here, the leading 0, means if the day has only one digit in it, there will be a leading 0 before that. So the width specifier is 2, and the 0 means I will print out 2 digits even if I have to put a 0 before it. So January 1st, 1970 would be 01/01/1970. Okay, that was kind of an aside and use of the percent sequences in a printf, and the purpose of this, make sure that we know what's going on. We define a function that uses our newly defined data type, and then we can pass an object of that type into the method, and all of this works the same as it did in using the primitives as you pass them by value. In this segment, we learned the keyword struct and how to use structs to define a new data type in the C language. Everything we do from now on in the language will probably involve some structs, some user-defined data types. So this is an important one to have a good grasp on right from the beginning. There are several different ways to use a struct in the C language. To define a struct, you can type def it if you want to, but you don't have to. So I broke the description of struct into 3 different approaches. I think this is important because people frequently will get the ways of using the struct mixed up and then not really understand what's the name of the struct versus the variable name and so on. So concentrate on understanding the 3 different ways of using the struct, and whatever textbook or Googling around to find more information on structs, it's not always clear that there are different ways of using it. So as you're looking at other sources of information on structs, make sure that you understand which of the approaches are being used in the documents that you're looking at. So the idea of a struct is that we can create new data types so that the code that we write can be expressed more in terms of the problems that we're solving instead of ints and doubles. Those data types are perfectly appropriate for solving mathematical problems, but if you have problems that involve customers and dates and other things that aren't in the short list of primitive data types, then you're required to define your own data types and use those in your code. So you throw around things that represent objects in the domain that you're programming in. And I hesitate when I use the word object because we're not really defining objects in C. It's not object-oriented. And although this is the basis or the starting point for what led to object-oriented programming, this is not object-oriented. So we're creating new data types, but we're not doing object-oriented programming, which you cannot do in the C language. I encourage you to adopt a standard for yourself for capitalization. Or if you're using a textbook, use their standard or their way of capitalization and stick with it. There isn't one way in all books that you use all caps or title case or camel case for using structs, defining structs. So adopt one way of doing that and be consistent with it so that you can read your own code. So I think that you'll probably come back and watch this one again, and when you get confused as you're writing code that uses structs, try to mix the writing of code and being frustrated by that with then going back and reading about structs in books that you might have or rewatching this video. So once you get to a certain level of frustration, then mix in some other learning as you go along, and it's just a faster way of getting to where you need to be in understanding this part of the language. Very good. I'll see you in the next segment.